a look at the second page of worksheet 21. We're going to call this video B. Again, there will probably be another video because, as I said before, this is a very long worksheet. Okay, let's look at number 4. It says given f of x is equal to negative 2x squared minus 8x minus 5, find the axis of symmetry, the vertex, and the maximum value of the function. So remember, you're going to find the axis of symmetry, at minus b over 2a. And remember, b is the second term attached to the x to the first power. So I have minus negative 8 over 2 times negative 2. It's going to give me an axis of symmetry of minus 2. So when x is equal to negative 2. Remember to find the vertex. I substitute the axis of symmetry. That's the x-coordinate of the vertex. I'm going to substitute that value into the function. So f of negative 2 is equal to negative 2 times negative 2 squared minus 8 times negative 2 minus 5. So I have negative 2 squared is 4 times negative 2. It's going to give me a negative 8. Negative 8 times negative 2 is going to give me a positive 16. And then minus 5. So I will have 3. So f of negative 2 equals 3. And you know that's the ordered pair negative 2, 3. And that is my vertex, negative 2, 3. So then it asks for the maximum value of the function. Remember, the maximum value is the y-coordinate of the vertex. The max or min is the y-coordinate of the vertex. So in this case, the maximum value is 3. Number 5, write each number in standard form for complex numbers. Standard form, remember, is a plus bi. So the real number is first, the imaginary number is second. And it asks you to reduce fractions and simplify the radicals. So a is the square root of negative 11. We know we have to simplify that. That becomes the square root of negative 1 times the square root of 11. Square root of negative 1 is I, so this becomes I times the square root of 11. B, we're going to add two complex numbers. Remember, to do that, we add the real parts. That's the A. So negative 3 and negative 6 is a negative 9. Then we add the imaginary parts. Negative 10i and negative 5i gives me negative 15i. So when adding or subtracting, you simply add or subtract the real parts together. C gives you the square root of negative 27 over 6. That will become the square root of negative 1 times the square root of 9 times the square root of 3 all over 6. The square root of 9 is 3. Square root of negative 1 is I. Square root of 3 is just 3 all over 6. And then, because 3 is a factor of 6, I can reduce that to I root 3 over 2. And that is the answer for C. D, I hadn't really talked about this much, but we will talk about it more in the next chapter. I to the third is actually I squared times I. I squared is negative 1, so that's negative 1 times I, so it becomes negative I. E is I to the 42. So if you think about that, actually, let's skip that problem. We'll talk about that problem next chapter. Okay, F asks us to FOIL or multiply these two complex numbers. So FOIL it. First, 1 times negative 4 is going to be negative 4. Outer, 1 times 3i is going to be plus 3i. Inner, negative 2i times negative 4 gives me positive 8i. And then negative 2i times 3i gives me negative 6i squared. Remember, I squared is equal to negative 1. So anywhere I see an I squared, I will substitute in that negative 1. And I'll combine like terms here, so it becomes negative 6 times negative 1. That becomes a positive 6, so the answer becomes 2 plus 11i. G, another one we didn't talk about very much, but we did talk about the complex conjugate, so we're going to go ahead and multiply numerator and denominator by the conjugate of the denominator. Remember, the conjugate just takes the imaginary term and changes the sign and makes it the opposite sign. So 2 plus 3i. FOIL, numerator and denominator. So here I'm going to get 10 plus 15i plus 4i plus 6i squared all over 4 plus 6i minus 6i minus 9i squared. Remember, I squared is equal to negative 1. So in the numerator, that makes that 6, a negative 6. So I get 4 plus 19i in the numerator. And then in the denominator, the reason I multiply by the conjugate is I want the i's to end up canceling. And you can see that they do. I squared is negative 1. That means that's a positive 9. So that makes that 13. Okay, and so that is rationalizing a complex number. We're not going to have that on this test, but you will see that next chapter, and you will see that on the next chapter test. Okay, number 6 asks us to use the quadratic formula to solve the equation. Remember, the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, that means minus 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2 times a. So I have minus 1 plus or minus the square root of 1 minus 4 all over 2. So minus 1 plus or minus the square root of negative 3 over 2. Simplify that. We don't want to leave a radical with a negative number. So it's going to become negative 1 plus or minus I root 3 over 2. So that is the complex solution that we found using the quadratic formula. Number 7 says use completing the square to rewrite the function in vertex form. Okay, remember the first thing in completing the square, that leading coefficient must be a 1. So a has to be equal to 1. And it is not in this case. I'm going to separate the terms with the variable from the term that does not have that variable. I'll factor a 2 out of the parentheses, so I have negative 2 times x squared minus 6x. Then I'll complete the square. Remember, completing the square, I take b over 2 and square it. So that's 6 divided by 2, which is 3. So I will add 9 inside the parentheses. But then remember, I'm working on the same side of the equal sign. So if I add it inside the parentheses, I have to subtract it on the outside. Then I must also consider the fact that I have a scalar multiplier on the front. So I have to multiply the 9 by a negative 2. So what I have really done is here I have subtracted, I have added a negative 18 to both sides. So therefore I must add 18 to maintain the integrity of that equation. Now I want to rewrite it so that the perfect square trinomial is written as a binomial squared. And there you have vertex form, where the vertex would be at 3, 7. You know it would open down. The axis of symmetry is at 3. You can find the y-intercept and the x-intercepts at that point. 7b asks you to complete the square to solve the following equation. So this time we're going to find the x-intercepts, and we're going to complete the square to do it. So this time, I'm going to put the 3 on the opposite side of the equal sign. So I'll have 2x squared plus 10x equals 3. And now I'll add to both sides because I'm working on both sides of the equation, not just one as in the previous example. Remember again, the leading coefficient must be 1, so I have to factor out a 2. So 2 times x squared plus 5x equals 3. You take minus b, you take b over 2 and square it. So 5 over 2 squared becomes 25 fourths. So I'm going to add 25 fourths to the left, but keep in mind that I have this scalar multiplier outside. Oh no, back up. I'm sorry. I forgot one very important thing, so we're going to start all over with this one. I was actually going for vertex form. That's not what I want. I want to solve this equation for x. So I'm going to start by dividing all of those terms by 2. Okay, when it's equal to 0, you want to divide everything by 2 here. Then move the 3 halves to the other side. Then complete the square and add your 25 fourths to both sides. Write your perfect square trinomial as a binomial squared. So x plus 5 over 2 squared is equal to, let's see, times 12. Multiply that by 2. No, 6 fourths plus 25 fourths. So I will have x plus 5 halves squared is equal to 31 fourths. Take the square root of both sides. When you do that, you will have a binomial on the left. X plus 5 halves is equal to plus or minus the square root of 31 over 2. Subtract the 5/2 from both sides. And you can rewrite that as one fraction. X is equal to -5 plus or minus the square root of 31 over 2. Okay, and that will do it for video B. So this is worksheet 21B. I will be doing video 21C in just a moment. Okay, thank you.